In this video, we'll be solving a boat in the river problem. Now, they're called boat in the river problems because if you ever put a boat into a river that has some current, you know that floating downstream, the current adds to your rate of speed, and so you go a little faster. And if you're trying to go upstream, the current will slow you down. So it's called a boat in the river problem, but as you'll see, sometimes it's not actually a boat in the river. Our problem that we're working on: one day Shelby found that her plane could fly at 5 times the speed of the wind. She flew 396 miles downwind in a half an hour more than it took her to fly 132 miles upwind. What was the speed of her plane in still air, and what was the speed of the wind? So you can see that we have actually a plane now in the wind, but it acts the same way. The wind will speed her up when she's going with the wind, downwind, and it'll slow her down when she's going against the wind or upwind. Now, to do a problem like this, I always organize my information with what I call a dirt box. So let me draw that here. And the reason that I call it a dirt box is because we're going to use the equation distance equals rate times time. So dirt. What we're comparing is downwind and upwind. Our first sentence says that she found that her plane could fly at 5 times the speed of the wind. So that gives me an equation that I can work with. I'm going to translate it directly from this sentence. Plane, and then could fly is our verb, so that's where the equals goes. I'll use P for the speed of the plane in still air. So plane could fly at 5 times the speed of the wind. So 5 times, and then I'll use W for the speed of the wind. So this is one of my equations that I'll be working with. Now let's fill in our dirt box with the information that I'm given in the rest of the problem. She flew 396 miles downwind. So 396 is our distance going downwind. So I'll put that number in this cell. In a half an hour more than, okay, so the downwind time was a half an hour more than the upwind time. So I'm going to let T be my upwind time, and then my downwind time will be a half an hour more than that. And let's see, half an hour more than it took her to fly 132 miles upwind. So 132 goes in the distance part of my dirt box for upwind. Now for boat in the river problems, these rates are what make the problem different from other distance equal rate times time problems. When I'm going downwind or downriver or with the current or with the wind, my rate of my vehicle is speeded up by the rate of the current or the rate of the wind in this case. So my plane rate has the rate of the wind added to it when we're going downwind. When we're going upwind, the wind slows down the plane. So I'll have my plane rate subtract the rate of the wind. Now, these will always be like this. You might have a B for boat if you're actually doing a boat in the river problem. All right, now, I know from here that my plane is equal to 5W. So I can sub that in and write 5W here instead of plane plus W. So this is actually a 6W that I'm going to use for my rate going downwind. And this one, my plane, again, I'll use 5W. And then minus W gives me a 4W that I can use for my rate. All right, now once all of the cells in the dirt box are filled in, I can use this equation at the top to get my equations that I'm going to solve. My first row, I have 396 equals, and then this cell, remember I use 6W here, times my time, which is a binomial, so I'll need it in parentheses, t plus 1/2. My next row gives me 132 equals, and then this cell I'm going to use the 4W times my t. All right, these are my two equations. I'm going to solve those simultaneously. I have two variables. Let's simplify this one. I have 396 equals, I'll distribute this 6W through here, so 6WT, and then multiplying that by 1/2 gives me 3W. And let's go ahead and take this one and divide both sides by 4. That'll simplify that. These 4's cancel, and I see that WT is equal to 33. All right. This I'm going to sub in into this equation in place of WT, because I'll have a number then, and the only variable I'll have here is the W. So this is 396 equals 6 times 33 plus 3W. 396 is equal to 6 times 33 is 198 plus 3W. Subtract 198 from both sides. These cancel, and I have just 3W on the right side, and on the left side I have 198 when I subtract. Divide both sides by 3. These will cancel, and I have W is equal to 66. Now this is the speed of the wind. I'm dealing with miles and hours, so this unit will be miles per hour. I'm also asked, not only do I need to know the speed of the wind, but I need the speed of her plane in still air. So I will use this equation. Plane is equal to 5 times W, and I'll put in my value for W now. So my plane is 5 times 66, and that gives me the speed of my plane in still air is 330 miles per hour.